Hello Year 11 and welcome to our third video here for further graphs. Today we're looking at absolute value functions, at graphing absolute value functions. Righto, now there's two different approaches that we need to take here really. We have the absolute value of x, that is we take the absolute value of the input perhaps, and when we take the absolute value of function x, when we sort of perform the calculation and then do an absolute value, we get fairly different results when we do that. Anyway, some things to keep in mind. First, sketch your function, and we're going to base our absolute value graph off the original function. So, if I'm doing the absolute value of the entire function, right, then I reflect it in the x-axis, right? If I am graphing the function of the absolute value of x, then I reflect it in the y-axis. I'll show you this in a pair of examples. So we want to graph the absolute value of x squared plus 5x plus 6. So this is the absolute value of the function, not the function of the absolute value. Now what that means is that my range, right, the outputs of this function, of this equation if you like, will always be positive. So it's all going to sit above the x-axis. Anything that might have sat below the x-axis instead gets reflected and flipped up. Okay, so here is a fairly familiar looking function. It's quadratic. It is concave up. We'll factorize it to see the roots are at 2 and 3. Oh, sorry, -2 and -3. They're the x-intercepts. The y-intercept is at 6. The vertex, calculated how you will, is at -2.5, -1/4. So here are my axes, and there's my original function. I haven't labelled everything here. That should be -2 and -3, and that's at 6. Now, you see that much of this function is greater than 0. That's good. But some little bits here, in fact, between -2 and -3, this part here is negative. So what I will be doing is taking the absolute value of these. In fact, it tells me the vertex will be, it'll still be at -2.5, right? I can have a negative value of x. I just can't have a negative value of y, right? Because I'm taking the absolute value to get y. So my new vertex would be at -2.5, +1/4. So we're just going to trace over the positive bits first. They haven't changed. Okay, if x squared plus 5x plus 6 is positive, then the absolute value is exactly the same. But where that's negative, right, I change that to be positive. So this little curvy part here, goes up the top. It's got a bit of a bump in there. Should be a bit smoother, but it's not always that easy. So there we go. That's the absolute value of my parabola there, of my quadratic. This time I want the absolute value, I want the sine of the absolute value of x. So what we're really talking about here is my domain is all real x. However, in many ways it's as though I'm only dealing with positive x's. I'm only going to be taking the sine of a positive number. Right. So this is y equals sine of x. Right. Lovely graph. You can see I've plotted that on Desmos and copied it because it's neat and tidy. Anyway, the bits to the right here, values where x is positive, not function x, where x is positive, right, they don't change, right? If x equals 100 here, right, the absolute value of 100 is still 100, so anything to the right of the y-axis remains exactly the same. On the left, however, it's not exactly the same. So if, for example, I mentioned 100 and I got a value of whatever that is, a little bit less than 1, then if I do the sine of, so if I let x equal -100, then I do the absolute value of that and I get the sine of 100. I should say 90, shouldn't I? Yeah. So the sine of 90 is, of course, 1. Now, the sine of negative 90 would be negative 1, but the sine of the absolute value of negative 90 is the sine of 90, so that means that the sine of negative 90 is 1 up here. Right, so what happens is this part here is reflected in the y-axis, and I get the same thing over here. Okay, like that. Now you see how we have a mirror image on the y-axis, right? The y-axis is an axis of symmetry, or a plane of symmetry there. Rightio. So that's the difference between an absolute value, the absolute value of a function, right? In which case you flip any negative values above the x-axis, and the function of an absolute value, in which case the right-hand positive side is mirrored in the left-hand negative side. Okay, absolute value of a function, start with function. Righto. For the absolute value of a function, anything below gets flipped up. For the function of an absolute value, the right-hand side is mirrored on the left-hand side. Righto, that's it. I don't want to hold you up too long. If you've got any questions about those things, let me know. Sort of have a go at some questions, mess around with them a little bit. Maybe have a look on Desmos, and you can always try things out there to see if that can put your mind at ease. But certainly, jot down the questions so you don't forget to ask me in class. Okay, thanks year 11. See you next time.